Hey guys, I'm back with another question from 2020 September exam, from basic electronics exam. The question is, a certain OPAMP has an open loop differential voltage gain of 1 lakh and CMRR 4 lakh. Determine common mode voltage gain and express CMRR in decibels. Okay, this is a very simple problem numerically, okay, but the question here is, what is a CMRR? What do you know about CMRR? Okay, let me tell you a few things about that first. So CMRR is a common mode rejection ratio. Okay, this is a parameter of an OPAMP. Okay, you know an OPAMP is a device like this. Okay, it has one output terminal and two input terminal, minus and plus. Minus is a inverting terminal and plus is a non-inverting terminal. Okay, and we can use this OPAMP, a device OPAMP, in at least two ways. Okay, in one way, we can connect the input voltage Vi, okay, an AC voltage like this, between these two terminals, in this way, plus and minus. Okay, so this mode of using this input mode is called differential input mode. Okay, so you are giving input as a difference in voltage between these two terminals, inverting terminal, non-inverting terminal. And it is this gain, it is given here. Differential voltage gain of 1 lakh means when you use the OPAMP like this, it has a differential gain of 1 lakh. Okay. Another way of using an OPAMP is something like this. The output terminal is here, negative and positive. To both of these terminals, you will apply a positive voltage like this, plus minus. Plus minus. Okay, this will count in that. So both of these are same. Okay, they have same magnitude. Okay, and this type of inputs are called common mode inputs. Common mode inputs. Okay, so in reality, these are not separate. Okay, when you apply a differential input, when you want to use OPAMP in differential input mode, okay, some noise will exist in a common mode input form, in the form of common mode input, okay, which is present at both of these terminals. And this Vi and this VCM are maybe of different frequencies, which will not give the desired result. Okay, so an OPAMP must have the ability to reject the common mode signals, the signals that are common to both the terminals. Okay, here both the terminals have different voltages, a differential voltage. Here both the terminals have same voltages, so that is common mode input. And OPAMP must have a high rejection ratio, a high rejection capacity for common mode inputs. That's why common mode rejection ratio is a 4 lakh here. Okay, ideally it is infinite, and that is what common mode rejection ratio is. Okay, and the formula for common mode rejection ratio is CMRR is AD over AC. Okay, where AD is differential voltage gain. It is differential voltage gain. Okay, and AC is common mode voltage gain. So I said CMRR should be very high. That means AC should be very low. Ideally, this common mode input, common mode voltage gain should be 0. Okay, so whatever common mode input you give here, output must be 0. Okay, let's find out in this case what is common mode voltage gain. How do you find? We know CMRR, we know AD. So AC or common mode gain is, if you send AC this side, CMRR this side, it is AD over CMRR. So AD is 1 lakh here and CMRR is 4 lakh. So it is 1 over 4. So common mode gain is 0.25. It's almost equal to 0. It is 0.25. Okay. So in this case, a practical OPAMP has a common mode voltage of 0.25 volts. Okay, and we need to express CMRR in decibels. How do you express any numerical value? This is a numerical value of CMRR. 4 lakh is a numerical value of CMRR. And how do you express any numerical value in decibels? You either use 10 log base 10 numerical value or 10 log to the base 20 numerical value. Sorry, 20 log base 10 to the numerical value. And CMRR, you use CMRR in decibels is 20 log to the base 10 into numerical value. Numerical value is 4 lakh, right? So if you substitute this in the calculator, making sure that log, you are not using natural log, you are using log to the base 10, you will get a CMRR of 112.04 dBs. Okay, so CMRR in dBs is 112.04. It is usually in the range of 60 to 120. Okay, and this is the formula you should remember for CMRR in dBs: 20 log to the base 10 into numerical value. Okay, so that's it for this question. If this video helped you and if you want to learn more, check out our full basic electrical course. The link is in the description. Also, like this video and share it with your classmates, and subscribe to the channel and press the bell icon to keep learning.